Welcome to Brain Vision.
Hi everyone. What we have is oxygen that is in 10 compressed tanks that have a volume of 1.5 cubic feet each. The initial pressure is 1500 psi and the initial temperature is 80 degrees Fahrenheit. The tanks are opened to a point where the final pressure is 300 psi. What we're asked to find is the mass of the oxygen that was used and the total heat transfer. So if we just look at what we have 10 tanks, so N is equal to 10. We have a final pressure of 300 psi. We have an initial pressure of 1500 psi. We know that we're going to assume that the entire process is isothermal, so we know that the final temperature is equal to the initial temperature, which is equal to 80 degrees Fahrenheit. And we know the volume of each tank is 1.5 cubic feet. So what we're first going to do is just look at the properties table to find our specific heats and gas constants for oxygen. And we see that our gas constant is going to be equal to R, which is 0.06206 BTU per pound mass Rankine. We find that our specific pressure, heat capacity, is 0.219 BTU per pound mass Rankine. And our specific volume, heat capacity, is 0.156 BTU pound mass Rankine. So what we're just going to do actually is just use ideal gas law and find the initial and final masses. So what we can do, ideal gas law is basically PV equals MRT. We can isolate and solve for mass and see that M is going to be equal to PV over RT. So what we're going to do first is just do M1. M1 is going to be equal to P1 V1 over RT1 times N, because M1 is the total mass that we have in the beginning in those 10 tanks. So we actually have all these quantities. We know N is 10, we know the initial pressure, we know B1, we know R, and we know T1. So once we plug all of these quantities in, we see that the initial mass is a 124.27 pound mass. Now we're going to do the same thing for M2, and so M2 is going to be equal to P2 V2 over R T2 times N. Now you'll notice that the volume, R, and temperature, and N, so these quantities will all be the same. The only quantity that's changing is pressure. So we'll plug in these quantities and we'll see that M2 is equal to 24.85 pound mass. So the total mass of oxygen used is just going to be, we'll say M tot is equal to M1 minus M2, which is going to be equal to just the difference between those two quantities we just solved for, so 99.42 pound mass. And that is the mass of oxygen that was used. So that's one part of our answer. We're also asked to find the heat transfer to the tanks. So we'll see that we're just going to define the system as our tanks. So we can just actually go ahead and write the energy balance and say that E in minus E out is equal to the change in energy of the system. And we can go ahead and say that we have heat transfer coming in. That's going to be, E in is going to be Q. We do have mass leaving, and that's going to be Q minus the mass leaving, so M out, H out, is going to be equal to the change in mass of our entire system, which is going to be, M1 U1 minus M2 U2. So these are our corresponding terms. So Q is just going to be equal to M out, H out, plus M1 U1 minus M2 U2. Now you'll actually see that we actually have most of these quantities. We actually have all of these quantities. So M out is just the mass total that we solve for that is leaving these tanks, so that'll just be M total. H out we can actually rewrite in terms of temperature and our specific heat capacity with respect to pressure. So that's just going to be Cp times T plus M1, we know. That is, we solve for that using ideal gas law. U1 we can rewrite using, again, temperature and our specific heat respect to volume. So that's CVT. And M2, which again is going to be CVT. Now remember that the T's are all the same because we're assuming this is an isothermal process. So plugging in for these quantities, we'll find that the total heat transfer to the tanks is 3,382.3 BTU. And that is our heat transfer. That's our final answer.